Now good afternoon. In continuation with greatest integer function and definite integration, one more problem I want to take. The problem is of like this: integration of 0 to pi greatest integer of cot x dx. Now this is a wonderful problem. See, if we think about the range of cot x, so what is the value of cot 0? Cot 0 is cos 0 upon sin 0, that is undefined. Cot pi by 2 is 0 and cot pi is also undefined. So in first quadrant the value is positive. So here we will have plus infinity, and in second quadrant we will have minus infinity. So if I plot the graph of cot x, it will be something like this. 0, between 0 to and pi only I am interested, because I have to integrate between 0 to pi. So you can see that 0 and pi it is undefined. So just after 0 it is infinity, that at pi by 2 it is 0, and then it is minus infinity. So you can see that between 0 to pi the value of cot x belongs to minus infinity to plus infinity, and the greatest integer function gives you an integer as the output. So between minus infinity to plus infinity there are infinite integers. So with that particular method we cannot solve this question like we did in the previous video. You got my point? So we should have a different method to solve this question. Now very interesting method I am going to tell you. So in spite of knowing the graph, in spite of knowing the range and domain, we are not able to solve the question if we don't know the property. Now if we apply a property here, so it can be written as 0 to pi greatest integer of cot of pi minus x dx. This property is known to everyone. A to b fx dx can be written as a to b f of a plus b minus x. Now it becomes 0 to pi. In second quadrant cot is negative, so it will become greatest integer of minus cot x dx. Up to this point it is very simple. Now if I add these two, this is 1 and this is 2. So it becomes 2i barabar 0 to pi greatest integer of cot x plus greatest integer of minus cot x dx. Again I am telling you why I have done this, because between 0 to pi value of cot x is ranging from minus infinity to plus infinity. So I cannot take out the integers because there are infinite integers between these intervals. Now if you see this greatest integer of x plus greatest integer of minus x, we have studied this always, that greatest integer of x plus greatest integer of minus x will be what? Suppose I take 2.1. So 2.1 greatest integer will be 2, minus 2.1 greatest integer will be minus 3. So this answer will be minus 1 unless these are integers. So we are not talking about the integral value. So this 2i will become 0 to pi minus 1 dx. So this is equals to minus x. Limit applied from 0 to pi, that is minus pi. So answer to this question I will be minus pi by 2. So this is what I wanted to explain from this very small question, that it is not always possible to break it into small intervals and bring these small integers outside. Sometimes you need to apply the property also to make this question very simple. Now if I analyze the question, this is the property of definite integral, this is the property of definite integral. If integration part is concerned, I have integrated only this term. So again you can observe that definite integration involves a very less kind of an integration. This is how it is. So this much was my idea to explain you from this particular question. Let's move to our next video. Thank you.